So here's how we do our final project. So as I've mentioned in the previous video, we're going to have to use Google Colab for this. You have to either be using a Linux machine or something that's Linux-like, so Windows won't work for those of you that are running locally on Windows. So I've set this up in Google Colab, which can run the Julia CHEM code. So the first thing you're going to need to do is open colab.google or research.google.com, copy and paste in the final project GitHub repo, and it will open up this, and you can click it. I'm not going to click it because I already have one open with it. And then you run this shell script, which will initialize the Julia environment. If your Julia environment is working, this little thing will work. You then need to upload, so you can just drag and drop the template JSON file that you would have downloaded from here. And then you need to run the helper scripts. Just make sure that it says this down at the bottom, that it's done, so that this code will then know what to do and run it, and then it will crash because so if that crash happens, just rerun these helper scripts. They're the things that are causing that to fail because they're not done loading yet. I was too hasty. So there we go. Those are done. Now we should be able to run this without any problems. This will take a second to load everything up. So we'll let it do its thing. I guess while it's happening, I will give you an overview of what this is doing. You're going to want to, I only ran one calculation here. You're going to need to do multiple. And I think the one that's loaded in the project site also is running two. You're going to need to modify this. This is just example code. Don't think that this is exactly what you need to do. You almost could just start from nothing using these things as long as it uses start and end calculation. So this just runs this example function and then does some plotting. So this is the method you use, and you pass in the distance in atomic units. You're going to want to plot, so instead of plotting this random data that I have, you're going to want to plot, your actual output. Energy 2 not defined. Yeah, that's because energy 2 isn't defined. Let's run that again. So just make sure that this week that this stuff can run and that you get plots. This will plot here in a second. I will scroll up. Sorry for jumping around so much. So this is the function that you're going to want to use. This all handles everything for you, so you're just needing to call this function. You can scroll back down. So we plotted some stuff. Again, don't take this stuff verbatim. This is just some example of how to run one Hartree-Fock calculation on H2. You're going to need to do a set of them. I'll give some more detailed instructions in the following video in the final module, but I just want to make sure that this is all working for you guys before you get in there, especially since we're using a slightly different setup and technology. As per usual, if you have any questions, let me know. I am happy to help and answer them. See you in the next one.